Hey guys, welcome back. It's day I don't even know anymore of quarantine, and clearly I've given up on how I look. So we are back with the next lesson. Sorry I did not give you one before. I wasn't feeling great, but we're back now. So we're going to focus on 6.5 properties of logarithms or logs, which I'm kind of bummed about that I'm not in class to teach you guys this because it's one of my favorite topics. Good news is there's really not that much math involved. It's more of like a puzzle and using the calculator. So you guys should like this, nice and easy. So the properties of logarithms are very similar to the properties of exponents, where you have the product property of logs, which if you remember multiplication, product means multiplication. So if you remember multiplication, for exponents, the rule is when you multiply, you add. So that's the same rule that applies here, except now instead of exponents, it's going to look like logarithms. So let me give you an example. If I were to give you log base b, b always represents the base. If there is no base, you assume it's 10. So log base b mn would stretch out. So when you multiply, you add, right? So that would stretch out to be log bm plus log bn. So all I did was split the m and the n up into addition, and I kept that common base. So when you're expanding these, when you're making it from shorter to larger, and I have two variables or even a number and two variables, you have to count the number of things you have. So I have 1 and 2. Everything after that log or after that natural log, ln. So I have two things, so I should end up with two terms. Okay. Then I have quotient property. So quotient means division. And when you divide, you subtract. Okay, so an example of that. If I gave you log b m divided by n, that would break down into, again, we have two things after the log, so I'm going to have two things when I rewrite it. Log bm minus, because when you divide, you subtract, log bn. So the only one that's different is the power property. So when you did a power to a power, you multiplied it. So it's the same concept. You do multiply it still, but you're going to have to relocate that exponent to the front. So when you have an exponent, you have to relocate and multiply. Relocate and multiply. So for example, if I have log b m to the n, in order to multiply by n, I have to bring it to the front. I have to relocate it to the front. So this would be n log base m. And that's it. Those are my three rules. So we're going to work with expanding and condensing, where expanding is making it bigger, condensing is doing those rules backwards and making it smaller. But we'll get to that one by one. Okay? All right. It's kind of like that awkward silence. And again, guys, if I haven't said it enough, I miss you guys more than you realize. It's been tough. I hope you're all doing okay. I hope your families are all safe and happy, healthy. You guys are finding ways to keep yourself occupied. And if you ever need anything or you need to talk or anything like that, I am always here for you. Okay? Just want to put that out there. All right, so first example. These are usually the ones that the kids don't like the most. This is usually the least liked one. So using properties of logarithms. And just for shortening, I'm always going to probably put properties as logs, logarithms as logs. It just makes it quicker. So I'm going to give you two things here. I'm going to tell you, and if you were to put this in the calculator, you would get the same thing. I'm going to tell you that log base 2 of 3 is approximately 1.585. I'm also going to tell you that log base 2 of 7 is approximately 2.807. So I'm giving you that. You don't have to find it. I'm giving you that. What I am going to also give you is different logs to evaluate using only those numbers. That is all you can do. So you're going to use the properties logs in these numbers. So let's start with the first one. So in A, I'm going to give you log, a nice easy one to start, base 2 of 3 over 7. Let's start with an easy one. So I have division. I have 3 divided by 7. This one is easy because I already have the 3 and 7. I don't have to like divide or make numbers up using 3 and 7. I already have straight up 3 and 7. And if you remember from the properties of logs, when you divide, you subtract. So let's expand this first. So this would break down into, remember, I have 1, 2. I have two numbers, so I should have two things. Log base 2 of 3 minus log base 2 of 7, because when I divide, I subtract. So now that I know that it's just log base 2 of 3 minus log base 2 of 7, I can just plug in the numbers I already gave you and just do the simple math. So I told you log base 2 of 3 is 1.585 minus 2.807. Plug that into your calculator, and you should get negative 1.222. Simple enough, right? Okay, let's do another one. Okay, so the next one I'm going to do, B, is log base 2 of 21. Log base 2 of 21. So this one's a little bit tricky because you're like, oh, there's not a 3 or a 7 anywhere, right? Sorry, apparently my TV ghost turned on the TV. It does it all the time. It's weird. All right, so again, it's a little bit different this time because I have 21. I don't have 3 or I don't have 7. But hopefully those of you that know your multiplication tables know that 3 times 7 is 21. So I know 21 is 3 times 7. And when I multiply, I add. So I'm going to break that down. So I have log base 2 of 3 plus log base 2 of 7. Again, I'm adding because product. When you multiply and you expand, you add them together. Well, now I have the numbers I have. I just fill them in and do the math. So I know this is equal to 1.585 plus 2.807, which gives me 4.392. All calculator work. Hopefully still pretty easy. Okay, the next one's where it gets a little bit different. Okay, so I can do the next one of two ways. Doesn't always work out like this, but in this case, I could do this one of two ways. I could either do 7 times 7, but I just did an example like that. So if I did 7 times 7, I would do log base 2 of 7 plus log base 2 of 7. I'd add this number together 2 times, and that'd be my answer. But since I already did multiplication with you, I wanted to show you how to do this one with the power property. So in order to do the power property with 49 using 7, this would have to represent 7 squared, right? So this would have to represent log base 2 of 7 squared. Now I know I can't leave it like that because when I have a power to a power, I have to multiply, right? In order to multiply, this guy has to come to the front. So I have 2 times log base 2 of 7. Well, all I have to do is plug that guy in. So 2 times 2.807, which again, so if you had 2.807 plus 2.807, if I did the 7 times 7 from the beginning, it would get the same thing. That would give me 5.614. Done. Good? I don't know why I'm asking you like you're here. I'm literally losing my mind at this point. But so we're done with example 1. 1 second for example 2. Okay, well, one good thing about my TV awkwardly turning on before is that I discovered the pause button. So example 2 is already up here for you without having to waste any of that time. So we are now going to expand a log expression. So again, expanding and condensing was one of my favorite things. So I wish I was there to teach you guys this in person. But so we are going to expand this. So this is when I was talking about count how many things there are. So there are 1, the 5 is 1. The x to the 7th is 1 because it's an exponent, they're attached. So that's 2, and the y is 3. So after my ln or my log, I have 3 things, which means I'm going to need 3 ln's. And then I can put those different pieces in order. So I start with my 5, and then I have my x to the 7th, and then I have my y. So that's what I do first. I break them all apart, nice and easy. Now I want to add my plus and minus signs based on whether it's a product rule or a quotient rule. So 5 times x to the 7th is addition, and divided by y, denominator. Anything in a denominator is always going to be subtraction because you're dividing it. So minus ly. So you would think we were done, but we're not, because you can't leave power rules. So the power rule is the last thing that you do here. So when you get to condensing, it would be the first thing you do. You do the reverse. So we have to get rid of that x to the 7th. We do that by bringing that exponent to the front of that term, not to the beginning of the equation, to that term. So ln to the 5th, or ln 5 stays the same. We bring that 7 to the front minus ln y. So when you finish and you're completely done, everything will be on one line. There shouldn't be any exponents or anything like that. So that one's done. Okay. We got the next one. Now here I don't have to pause it because it's quick. Okay, so the next one's a little trickier. So log base 6 to xy cubed. All right, this one's trickier because it has a radical in it, and let's be serious, usually when you guys see radicals, you freak out. So the only difference is whenever you see a radical, whether it be square root, cube root, fourth root, fifth root, it doesn't matter. We're going to convert it into an exponent fraction. So remember, exponent over root. So the exponent is technically 1. Square root is an invisible 2, right? Cube root is 3, fourth root is 4. So we're going to rewrite this as log base 6 of 2 times xy to the 3rd to the 1/2. The 1/2 represents that square root. I'm so sorry, I'm writing at an angle. I can't tell when I'm writing. Now we have to distribute it because we have to get rid of our parentheses. Okay, order of operations still, parentheses come first. So I'm just going to distribute that 1/2. Remember, when you have a power to a power, you multiply, properties of exponents. So then x to the 1/2, 3 times 1/2 is 3/2. So there we go, I got one line. Now I can expand it. So after the log, I have the 2, which is 1, because remember the base is attached to the log. So I have 2, which is 1, x to the 1/2, which is 2, y to the 3/2, which is 3. I have 3 things, I need 3 logs. Log base 6 of 2, log base 6 of x to the 1/2, log base 6 of y to the 3/2. I split all of those up. Now, depending on where they're at, I can add my plus and minus signs. They're all on the same line. It's all multiplication, which means they're all going to be plus. So we're almost done. The only thing is now we have to use the power property to get rid of those exponents because everything should be nice on one line. So this one doesn't have an exponent, so I'm going to leave it. This 1/2 needs to come to the front of its term. So plus 1/2 log 6x. And the 3/2 have to come to the front of this one. Log 6y. And then we're done. That's my final product. I expanded it all the way. Okay, we got one more of those and then we'll go to condensing. Okay, so we got log base 3. And we're going to do 5x squared over 4y. Okay, 5x squared over 4y. So we have log 3. That's our log. How many things after? 1, the 5 is 1, x squared is 2, 4 is 3, y is 4. So we have 4 things. I need 4 logs. So I have log base 3 of 5, log base 3 of x squared, log base 3 of 4, log base 3 of y. Now that we separated it, I need to put in all my signs. The top is multiplication. You're adding those together. So that's an invisible plus sign. These two are on the top. These two just get added together. That's it. But both of these are in the denominator. They're both being divided, so they're going to be negative. Anything in the numerator is positive. Anything in the denominator is negative. Easy way to remember it. So the last thing to do is just get rid of that one exponent. Now, if we were in class, you all know that there would be somebody that says, do I have to show the extra step? No. So if you can go right from here to here, if you know the exponent has to come down, that's fine. You can skip that step. But until you get good at it, I recommend writing all your steps out. It just will make it easier. It takes 2 extra seconds. Okay, we'll be right back with condensing. Okay, so now we're going to condense. So we're taking the long thing and we're making it the short thing. Makes it a lot easier. So since you always ended with the power, now we're beginning with the power property. So doesn't have a power property, no number in front. Doesn't have a power property, no number in front. This one, however, does. So we're going to fix that guy first. Okay, so as you guys can tell, there's no base to this log. That's fine. If they don't give you a base for a log, you assume that it's 10. It's just then it will cancel out. So sometimes they don't write it when it's a 10. Most of the time they don't. They only write it when it's anything other than 10. So if it's not there, you assume it's 10. All right, so now we got log. We want to condense this into one thing. So all I need to do is write one log. Okay, I have pluses and minuses here, which means I'm going to need a division bar. It means they're not all on one line. So remember, anything positive goes in the numerator. So I have 9. And when you add, you multiply. So 9 times 2/3. 2 to the third. And then minus, anything negative goes on the bottom. So divided by 3. Now that can be simplified because it's all numbers. 2 to the third is 8. So I have log of 9 times 8 over 3, which if you put in the calculator, you get 72 divided by 3, which is log of 24. Not all of them will come out to be able to do that. Not all of them will have numbers that are nice and pretty. Some will have variables, which I'll show you in the next one that you can't simplify any further. But if it is just numbers, you have to simplify it. Okay, so for B, it has a variable, so it'll be a little different. But you still start off with, are there any power properties? Are there numbers in front? Well, here there is a number in front. Again, you cannot do anything if there are numbers in front of terms. You can't combine it. So first I'm going to pop that up. Okay, so I pop that up. Now I can combine it into one thing. So there's only a plus sign, so I don't need a division bar because it's all on the same line. It's all positive. So all I have to do is multiply. So I squish them. So I take adding and I turn it into multiplying. And that's it. Now, if you want to change this to ln of 5 of the cube root of x, that's fine. You could do that because x to the 1/3 is the cube root of x, but I'm not picky. You can leave it as this. Okay, one last thing. Okay, so for this last one, I combined examples 4 and 5. I wrote them out a little longer on the notes, but there's no reason that we can't squish those together for the video. So the very last thing is the change of base formula. So not all of your calculators are nifty, and they don't have a button that allows you to put this base in. All it says is log, and that's it. So that's how you get around that when you're trying to plug it into the calculator. You use the change of base formula. So this is really simple. I'm going to show you how it's done pretty quickly. So if you have the base, I like to think the base as the bottom. The base goes on the bottom. So if you have log base b of a, log a goes on the top, log b goes on the bottom. You can also, this is example 5 over here, you can also use the natural log, ln. So if you have log b of a, ln b is the base, ln of a goes on top. Let me show you too how to do that. So say I gave you log base 3 of 8. Now, I don't even think my calculator has it. It might. Let's say it doesn't. See, so a regular calculator doesn't have the option for you to put the subscript in. So we have to change it so we can easily put it into the calculator. So this is my base. It has to go on the bottom. So I have log 8 over log 3. And I can just plug that into the calculator now. I'll show you guys how I'm doing it. Or you can, I use the division button, but you can use the fraction key if you want. Hopefully you can see that well. And you can round, 4 decimal places, 3 decimal places is fine. Please don't round to the tens. We don't do that with logarithms. We like a little bit more precise answer. So I'm going to do 1.89. I'll use 3 decimal places, so you can do 3. Okay. Now I also want to show you real quick how to do this with ln. It's the exact same thing. The natural log, ln, and log are the same setup as long as it's a base of 10. Which when you use the change of base formula, you're converting it into a base of 10. That's why the subscript goes away. So if I gave you log 6 of 24, I could set that up one of 2 ways. I could say log 24 over log 6, or I could also do ln 24 over ln 6. Natural log. Some teachers would have my head for saying ln. And this one, I'll show you how to do it with the fraction button. So on my calculator, ln and log are here, but the other ones might be a little bit different. And again, we're going to round that to 3 decimal places, so 1.774. And that's it. Hopefully this helped you guys. If there's anything you need that can help you, please don't hesitate to ask. Please ask questions when you're confused. You're going to need this for pre-calc. You're going to need it for the SAT. So please, 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 if you ever need help, I try to get back to you as fast as I possibly can. But I will give you the rest of the week to do this one because it takes a little bit longer, but hopefully this video helped, and I hope you guys have a good rest of your week.